this later. All right. So y is greater than 2x minus 1. So this should look familiar. This is a y equals mx plus b form or a slope-intercept form. So this -1 is your y-intercept. So I'll start at -1. And this is my slope, which is 2 over 1, which means 2 rise over 1 run. So 2 up, 1 right, 2 up, 1 right. And I could technically go backwards, 2 down, 1 left, 2 down, 1 left. I'm just reminding you how to graph y equals mx plus b. Okay, so you just connect the dots, you have a straight line. But this is not equal, this is an inequality. So first thing you should note, I'll make this greater than or equal to, and then I'll talk about the differences between greater than and greater than equal to.
Mr. Theo, are you supposed to shade when it's like that, right?
Yeah, you're supposed to shade, but we need to figure out where we need to shade, which direction we're going to shade. And how we do that is we're going to use a test point. Now, a test point is going to be any point that's not on the exact line. So you got to pick something that's not on the exact line. Usually the best test point is going to be 0, 0. Reason is, if you plug in a 0 for x and a 0 for y, you cancel out a lot of things. So your math just becomes less. So what I'm going to do is plug in 0, 0 and see if the statement is true or false. So I plug it into this equation. So y is 0 is greater than or equal to 2 times 0 minus 1. So I get 0 is greater than or equal to -1. Now, this statement is true. Because this statement is true, we always color to the truth. So this way, usually I do like little arrows to show it, but you could just shade it in. But your shading is going to be towards the 0, 0. And you guys could just shade normally, but usually I use arrows just to be a little bit better for myself. So we shade towards the truth. Now, anyone could offer, what if it was false? Let's say if it wasn't a true statement, what would we do?
Then you would shade the opposite direction. You'd shade downwards.
Absolutely. So in an alternate universe, let's say it was false. So if it was false, you would shade the other way, away from the falseness, because the other side has to be the truth. It's a very binary situation here. Either is or isn't. Either is the truth or not the truth. So you always color towards the truth. What's up?
Is there a difference between if you're shading if it's greater than or equal to or just greater than?
The difference is, and it's the issue, it's why I erased it beginning wise, is that if you have just greater than, it should be a dotted line. Kind of like the same way when we did inequalities, it was an open circle, while greater than or equal to is a solid line / a filled in circle. So those are the two differences. I already made it a solid line, and I imagine everyone already wrote it as a note as a solid line. So I changed it to greater than or equal to, just so I don't have to redraw it. Next one, I'll purposely make it just greater than or just less than, and we'll see from there. So not equal to is dotted, is equal to solid line. Okay, so that's the concept of just graphing one inequality. But we're not just graphing one inequality, we're graphing a system of inequalities. So let's do a very easy one first to start off. Y is less than 3, and x is greater than or equal to 2. And again, make yourself a quick 5 by 5. So I'll do it color coded. So y is less than 3. So this is a line where every y value is 3. So that's like 0, comma 3, 1, comma 3, 2, comma 3, 3, comma 3, or -1, comma 3. So everywhere where y equals 3. And since this is a less than and not a less than or equal to, this is going to be a dotted line. Next one, x is greater than or equal to 2. So every place where x equals 2, so every coordinate point that x equals 2, that's x equals 0, x equals 1, x equals 2, x equals 2 comma negative 1, 2 comma negative 2, 2 comma negative 3. And since this is greater than or equal to, this is going to be just a solid line. Should be straight. I crooked it up at the end. All right. So we're going to use a testing point. Again, the go-to testing point is 0, 0, unless 0, 0 is actually on the line. You cannot choose a testing point that's on either of these lines. So the first one we're going to plug in, 0 is less than 3. Because 0 is less than 3, that is a true statement. Because it's a truth, we would shade towards the truth. This is particularly why I use the arrows. So I would just do light arrows like this. And you'll see why, because I don't like shading it all the way because it makes it a little bit more polluted, especially since I still have another line to talk about. Mine's is color coded, so it's a little bit easier to track. But for you guys who's probably just using pencil, I recommend doing the little arrows. Now this one, x is greater than or equal to 2. So I plug in 0, 0. You could technically choose another testing point for this. You could use a different testing point for each one, as long as you still follow the pattern of you following the truth. So here, 0 is greater than or equal to 2. This case is false. This is a false. So we're going to color away from our testing point, or we'll put arrows here. And the testing point was 0, 0. Usually you would just want to indicate that to yourself in case if you had a different reason. Okay. Here, a system of equations, it's not one or the other. What I need is both at the same time. So it has to be true that it's y less than 3 and x is greater than or equal to 2. And the only place in this section where they're both true is where the arrows are hitting each other. And it seems like the arrows are hitting each other in this corner over here. So your final shade-in / area that you're shading together is this corner over here, not on the top right, top left, or bottom left. This has to be the top, bottom right. And the reason is that's where it's equal to. That's where they both have shaded areas. So it has to be where the overlap occurs. Before, in a normal system equation, it was just the overlap, like it's equals. It would just be the overlap of the two lines, so where the lines intersect. Here, we want the whole areas that intersect. So it's going to be that purplish area on the bottom right. And again, this is why I use arrows, because if I had a shade, and especially if I only had one color, it'll be hard to see where they both overlap or indicate it to myself. Maybe it'd be clear as you do it, but it's hard for me to grade it later. So I usually just do arrows. Any questions on that? Or we'll got at least 2 more practices. We'll do 2 lines, and then we'll do 3 lines, and maybe we'll do a parabola. All right, let's go to the next page. We have here, let's do y is greater than 2x minus 1, very similar to the first one. Let's do x is less than, no. Yeah, less than 2, less than or equal to negative 2. And let's do y is let's do less than or equal to 3. So everyone make your 5 by 5 and first graph it. So practice graphing it a little bit by yourself, okay? I paused the thing so I could graph it without you guys looking. So everyone try to graph it yourself first. All right. So your graph should look something like this. You kind of see the area is kind of more like a triangle. And that's okay. Like the inside area, and then you got these two, one horizontal, one vertical, and one diagonal. All right, same concept. We're testing a point. 0, 0 is all reliable, is not on any of these lines, so we can choose it. So I'm going to test each one. 0 is greater than -1. That is the truth. 0 is less than or equal to -2. That is true. And 0 is less than or equal to 3. That is true. Wait a second. 0 is less than or equal to -2. Oh, I'm sorry, that's false. It's false. And then 0 is less than or equal to 3, so that is true. 0 is less than 3, so that's true. Zero is greater than -1, that is true. Again, another reason why I use the arrows over the shading for each part is because it would be very ugly otherwise, or very convoluted and overcast. And then 0 is less than or equal to -2. So it's false, so I got to go away from 0, 0. All right. So where does all the arrows lay over? The only place where all 3 arrows, because we have 3 equations, has to be 3 things that agree. All 3 arrows lay over is here. So we shade this area over here. Even though this has 2 arrows, like over here, or this has, is there any other place that has 2 arrows only? I guess here technically has only 2 arrows, and here technically has 2 arrows. You need all 3 arrows. So it'll be in this kind of like far left. So that's a system equation with 3 parts to it. Any questions on that? I'll take it. All right. All right. Okay, let's go to the next one. This one's a parabola on the line. Of course, it could be also a diagonal line, but I'm just showing proof of concept. So of course, all these questions I'm bounding into like 5 and 5, just to make the graphing simple for you guys. I'll check the questions on the homework. If you be careful. I'll warn you if you need a 5 by 5, 10 by 10, or whatever. Okay, parabolas. If you don't remember how parabolas work, the A value tells you if it's going up or down, and the C value is your y-intercept. So x squared minus 2, that means my y-intercept is going to be at x minus 2. There's no b value in this function. So because there's no b value function, there's no horizontal shifting. So that means it is just at the vertex is also at -2. And then you make your parabola. You could plug it into a table. You could solve it out. If you plugged in -1 and 1, you'll get -1. If you plugged in 2 and 2, you would get +2. And you got your U shape over here. And then the other one, y is less than 3, less than or equal to 3. So here's a y line. Same concept. You're testing something. 0, 0 is all reliable. So for the first one, 0 is greater than or equal to 0 squared minus 2 minus 2. This is true. The other one, 0 is less than or equal to 3. That is true. So true is coloring down. For the parabola, you have to be coloring towards the thing here. So if it's on the inside of the parabola, it's all the arrows going towards the inside of the parabola. If it was outside the parabola, it would go to the outside of the parabola. Shaded region seems to be the inside of the cup right here, in the cusp, I guess I should say. And again, this is how you show your answer. It's a shaded region. It's a whole region, which means in this region, if I plugged in any X and Y in this region, it'll be true for both of them. Like 0, 0, if I plugged in 0, 1 into both of this, it will be true. If I plugged in, looks like -1, 2, it would be true. So this whole area, every point in this area would be true for both of them. And that's what you're kind of showing with the shading. Every point within that area would be true if I were to plug it into the system of equations. All right. Sadly, because of this is a graphing nature, I can't really give an exit ticket on this. And I feel like you guys pretty much got the concept. I'll put some homework. We'll do harder ones on Monday. Everyone, you could type here for your chat, for your attendance, and you're free to go. If you want to stay to ask me any homework questions, I'm happy to take that for the last, 15 minutes we got. If you want to go early, though, have a wonderful day.
Thank you.
Can you just go to the first slide?
First slide. We'll stop recording. It's not a lesson anymore.